Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic here we will discuss today it is the redox reactions that can be used to recover the metals from their ores. So basically the reactions that are used to recover the metals from their ores or the main process that we can use for this it is called as metallurgy. Now, the process of metallurgy is involving a lot of chemical processes that are basically redox in nature. So, first of all, you guys must know that what does mean by the redox reactions? It is a type of reaction that is involving the oxidation and reduction as well. So, here we have the two types of the atoms in general reaction, which the A is the atom that is going to lose electrons. When there is a loss of electron by an element, this process is called as oxidation. On the other hand, when there is a gain of electrons by one of the atom, this is known as the simple reduction process. And here the A is going to lose electrons and it is donated by A to B. So A undergoes oxidation and the B will undergoes the process of reduction. Overall, this reaction can be called as redox reaction. Likewise, if you want to recover the metals from their ores, basically the metals that are present in the form of ores, they may be the oxides, they may be the chlorides, they may be sulfides or sulfates of the different metals. Like the metals, we can have the iron, we can have zinc, we can have copper. So these are basically present in the form of their ores. So we have to separate out these oxides, chlorides, and sulfides from them by the simple process which is called as the redox reaction. So now how we can be able to recover the metal in the pure form, it involves the redox reaction. So let's have a look on this. Basically, the process of recovering of metals from their ores, it just happened in the blast furnace. So blast furnace is a specific type of apparatus in which we just put up the ore and it get react with the different reducing agent because they are present in the form of their oxide, so we have to remove that oxygen. We will use specific type of the reducing agents and this reducing agent reduces the ore and at the end we just gain the metal which is in the pure form. Here we have a lot of examples of the different ores of the iron and their reducing agents along with. So the first one ore of the iron which is it's basically oxide and iron will be present in the form of Fe2O3 that is called as iron oxide and the name of that mineral is simple hematite. That hematite is containing 70% of the iron. Now we have to just extract that by the use of redox reaction. The second one mineral or the ore of the iron is magnetite, which is having the formula Fe3O4. Here, the four oxygen atoms will be present along with this. It is having 72% of the iron in it. Third one, we have limonite. Its formula is Fe2O3. It is called as the iron oxide, but it is having some water of crystallization along with that that is present in the form of moisture. It contains a percentage of the iron is almost 59.8% that can be round off to the 60%. And the fourth one we have siderite, which is the iron, it's carbonate, iron carbonate, FeCO3, and it contains the percentage of iron in it 48.2%. So the highest percentage of the iron will be present in the magnetite and the reducing agents that we can use for the reduction of these minerals to the pure metals. These reducing agents are basically the first one we can use the coke as the carbon. We can use the carbon monoxide, its formula is CO, and we can use the hydrogen gas, its formula is H2. So these reducing agents can be used for the redox reaction, and that redox reaction will take place in the blast furnace. Now, the next we will have the simple transfer section of the blast furnace and how do that reaction just takes place. Just have a look on it. This is the simple transfer section of the blast furnace. It is basically a highly heated container. First of all, we have to put up here the iron ore, coke, and the limestone. So here the coke will work as the reducing agent, and the iron ore we will use over there, it may be a hematite. So we have to just reduce the hematite. When we just put up all these substances into it, a blow of hot air will be put up into it, and the temperature just rises up from 400 degrees Celsius to 1800 degrees Celsius, and the ore will be reduced with the help of the reducing agent at high temperature, and the molten slag, which will be the impurity, it will be gained at the end of the, and a tap of hole here from down where we will have the molten iron in the pure form. Now the hot of blast air will be inserted on the both sides to just melt the metal and to reduce it. So here we have a hole for the slag that it will be removed from there, and then the molten iron will be gained from this side. So the gases that will produce as a result of these reactions, they will be removed from the top of the blast furnace. These are the hot waste gases that will be removed after this process. So this is a simple transfer section of the blast furnace that can be used for the simple removal of the oxides. If we have the oxides of the zinc like this, we have the iron oxide. So we can use the reducing agents like coke and the hydrogen gas for the removal of their oxides and to get reduce these substances. In this way, we will get the metal. It will be in the molten form, and now it is having no impurities in it, and it is a pure metal. So this was all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that in a comment section. The next topic that we will discuss, it is the galvanic cell, which is the second type of the electrochemical cell. For that time, you guys keep learning and have a good day.